Today I'm going to begin with the topic how we'll compute the derivative using first principle method. So we know how to calculate derivative using formula, but this is a basic step in calculating a derivative from the start. So let us see how to calculate the derivative using first principle. So from here you can see that derivative is nothing but it is given as limit of h tending to 0 f of x plus h minus f of x by h. So this is valid only when f is real valued, only f takes only real values, real numbers, and also only when this limit exists. So if suppose this limit is infinity or undefined, then this derivative is also undefined. So similarly, I will explain with an example. For example, take f of x is equal to, let us take f of x is equal to tan x. So we'll compute the derivative using first principle method. So before that, we have to know few things. The one trigonometric identity, first of all, trigonometric identity of sine a minus b. So sine a minus b is nothing but sine a cos b minus cos a sine b. So similarly also on limit, already existing limit result, that is limit h tending to 0, or I can say that x tending to 0 sin x by x is equal to 1. So these two results need to be known. These two results, one is a limit one and other one is a trigonometric identity. So if you know this, and we are ready to go to solve this problem. So let us see how. So now let us put, instead of f of x, instead of x, if I put f of x plus h, then again instead of x in the right hand side you put tan of x plus h. So f of x plus h is nothing but tan of x plus h. So we got f of x plus h, and f of x is already there. So we will now substitute in the limit. So limit h tending to 0 tan of x plus h minus tan x by h. So now you might have thinking that now if I directly substitute, we cannot substitute directly h equal to 0 because the limit will become undefined. So there are two ways. Denominator since cannot be 0, I will try to simplify the tan h. Tan h I will try to write in form of I will write in form of sine and cos. Because whenever I have said already in trigonometry, in class 10 trigonometry lectures, that whenever you are dealing with trigonometric functions, if you don't understand what to do, you can directly write in terms of sine or cos. So I am going to write in terms of sine and cos. So what will happen? Uh, for time being, let me take that h outside. So if I take that h outside, then, and also I will try to put tan x is equal to sin x by cos x. So if I use this result, I hope everyone would already known this. So sine of x plus h by cos of x plus h minus, I can write like this, minus sin x by cos x. So this is, now let us take LCM. This limit is there, I am not going to write again and again limit. It is always a better practice to write, but I am avoiding it. So 1 by h, if I take LCM, then into cos x, and So I will take the LCM. Sine of x of into cos x minus, so if I multiply cos x plus h into sine of x divided by cos of x plus h into cos of x. So this is what we have got. So now I am going to further simplify this. So now you can see this is in the form of sine A cos B minus cos A sine B, where A is equal to, I will continue here, A is equal to, where A is equal to x plus h and B is equal to x. So what is A minus B? We can see that A minus B is x plus h minus x. So x minus x will cancel out. So remaining will be h. So now I can write in the form of sine of h. This whole numerator expression will be sine of h. So let me write that. So now 1 by h into sine h by cos some numerator y is there. Let me take this as well. For simplifying, no need, because this expression, let it be like that. So now sin h by h, already I have told that limit of x tending to 0, sin x by x is 1. So I can write this expression as 2. I can split this into two limits. So limit h tending to 0 sin h by h into limit h tending to 0 1 by cos x plus h into cos x. So now this is 1. This whole limit, 1 minute, I will change the ink. So this expression goes to 1. So this limit is tending to 1. So this is 1 into limit. So now if I put h equal to 0, then it will be cos x into cos x. So cos square x. So the answer will be, if I substitute h equal to 0, this is not, limit is defined. So you can see that clearly it is not 1 by 0 form or infinity by infinity or 0 by 0 form. So this limit is defined, and this is nothing but cos square x. 1 into cos square x. So 1 into anything is the same number. So if I write 1 by cos square is nothing but secant square x. So this is the answer. So tan x derivative is secant square x. We already knew directly, but this is using first principle method. We can compute the derivative in this manner. So let me also continue with product rule and subsequently product rule of differentiation. So product rule. So what is product rule? Suppose there are two functions u and suppose two functions f into g, and I want to find the derivative with respect to x. So what will happen? So this I can write as, rather I can take simpler form. We know that derivative, instead of writing df of x by dx, I can directly write it as f dash of x. This is first derivative. So this is equivalent to this form. So I will use this form now. Let the two functions be u and v. uv. So I want to find the derivative of whole derivative of u and v. So this is nothing but if I take u dash v plus, so anything you can take. You take a derivative of one and keep other one as same, and also uv dash. So this is a way to write it. So first we have to take the derivative of any one function and multiply with the other one without changing, and add and take the other derivative of it. So for example, let me explain with a simple example. uh, for example, if I take x square, so you know that both are same functions, but let me take x cube. So derivative of x cube is nothing but 3 into x square. You know, directly I can say without using the product rule. But for example, I want to use a product rule. I can write it as x into x square. So first I will find the derivative of x, that is nothing but 1. Derivative of x is 1. Then I will multiply x square plus, then I will write x square. I will write x square and then sorry, I have to write x, not x square. So already I have taken the derivative of x1, so again no meaning taking it again. So if I write x and take the derivative of x square, that is nothing but 2x. So this, I can write this as x square plus 2 into 2x is 2x square equal to 3x square. But as you see that this, when these type of for x cube, there is no meaning to apply a product rule. I can apply the product rule. I am showing because it is much easier to understand. But we have a direct result. If in case of x power n, you know that derivative, something like x power n derivative is nothing but n into x power n minus 1. This is a quite common derivative. So if I write this differentiation, so no need to write it. So I am writing it x power n derivative. Derivative is n into x power n minus 1. So suppose now I have a function like consider that I have sine square x. You know that sine x derivative, again one minute before that, sine x derivative is cos x. Cos x. Similarly, cos x derivative is minus sine x. So d of, I'm ignoring this step. You can always differentiation of. So this step is required. So what if I want to find the derivative of sine x into cos x? Find the derivative with respect to x. How will find it out? So let me write first. So for example, now I will take the differentiation of sine x, that is nothing but cos x, and write the cos x as it is. And then again I have taken differentiation of sine x, so now I will write sine x into cos x. Differentiation is nothing but minus of sine x. So this turns out to be cos square x minus sine square x. So now first I've used this way, and also I can use one more way because I want to show that both are equivalent. So now first I started by taking sine, differentiation of sine. So sine, I have taken u and this as v. Now if I want to take first, if I differentiate cos x, for example, I will write sine x as it is, and I differentiate cos x. Cos x is minus sine x. Then plus, since I differentiated cos x here, I have to write cos x as it is and then differentiate sine x. So again you are going to get the same result, minus sine square x plus cos square x. So this both are equivalent. You can take either u dash v plus uv dash. So the main point we have to remember, take care is that first we have to differentiate one function and then write multiply it with the other function without modifying it, then add again by differentiating the other function and keeping the other function same. So I hope this method is clear, but I'm going to start with one more simple thing. For example, if I want to find sine square, derivative of sine square x, so how I'll find it? As I already told you that sine square x is nothing but it's both same. So this is similar to x square, right? This derivative is similar to x square. So you know that x square derivative is nothing but x square is 2x. So first, instead of x there is, instead of x there is sine x. So what I can do is, let me change the variable to avoid the confusion. So if I take y square, it is 2y. So now y is sine x. Consider that y is sine x. Y square is sine square x. So what is the derivative? So 2y, y square derivative is 2y. So what will be sine square derivative? Sine square derivative will be nothing but 2 into sine x. Right. But this is wrong. Why? Y square derivative is 2y. This is not all right. But when we are differentiating with respect to wait 1 minute. Let us not confuse much. So if I take then it will be 2 sine x. So this is clear. But now I have to multiply with again this is chain rule. This is something called as chain rule. I am giving a shortcut rather in this can be used for so many complex functions. This is not product rule, but this is chain rule. First, if I differentiate, I treat it as sin x. If I treat it as a simple polynomial, then it is differentiation is 2x. Then writing it again, I have to differentiate sin x now, because sin x I didn't differentiate. So sin x differentiation is cos x. So this is chain rule, but now I am going to use a product rule. Product rule, as I mentioned, I can write sin x into sin x. Sin x into sin x. This is nothing but differentiation of this. I can write sin x into cos x plus sin x into cos x, because both are sines, so no meaning. Only sine I write and then differentiate other sign, then sine I keep and differentiate other sign. So this is nothing but 2 into sin x into cos x. So this is a straightforward method. Product rule is very important when you are dealing with two different functions. If you want to differentiate when they are multiplied with each other. Similarly, there is quotient rule. I am going to talk about it in the next video.